back to Maths with Mrs. J. Today I thought it was time for us to do another challenge. Now this one's very cool, partly because of how you do it, but also because of how simple the answer is. You'll be quite surprised. You might like to have a go at doing this yourself and then come back and check, or you might like to sit back and watch how I do it. It's a very, very interesting problem, this one. Okay, what I would do first is I would say, let this whole expression, so I'd say let that, let's just change our colours here. I'd say let x be those two things added up together. It also makes sense to talk about the expressions under the cubed root sign. So let a be our 8 plus 3 root 21 and b be our 8 minus 3 root 21. Now we should notice from the outset that a and b are conjugate surds. So let's actually work out what AB is, just for interest, because that probably will come in at some stage down the track. So AB, multiplying our conjugate surds, we're going to get 8 squared minus 9 times 21. And beautifully, that comes out to be negative 125, which is negative 5 cubed. All right, so already we're discovering some cool things here. Okay, so we said let x be this. So x is really, what we're saying is, x is really the cubed root of a plus the cubed root of our b. Well, why don't we cube x? Now, be careful here. If you cube x, you are not just going to get a plus b. Because, just bearing in mind, let's do it with different letters. If you had c plus d all cubed, the expansion is c cubed plus 3c squared d plus 3cd squared plus d cubed. So when we cube this, yes, we will get an a plus a b, but we'll also get some other terms. So cubed root of a cubed is just a, which is fantastic. Then we're going to get 3 times that squared times that. So we're going to have the cubed root of a squared times b. Then we're going to get 3 times this squared. So cubed root of a times b squared. And then plus our cubed root of b cubed is just b. Now, what do we notice about the a squared b and the ab squared? Well, they're each products that are divisible by our AB. And we're wanting to take the cubed root of that. So that will help us simplify that cubed root. Let's just put our A plus our B together and maybe plus our 3 here. And what we've really got here is we've got the cubed root. So if we've got A squared B, that's a times AB. If we've got AB squared, that's b times AB. Right, and that AB we said was negative 125. So what we've really got here is the cubed root of a times negative 125 plus the cubed root of b times negative 125. Now we know when we're simplifying, we can bring that cubed root of the negative 125 all the way out the front. So let's do that. So we get a plus b plus 3 times. So we're going to get, well, 3 times negative 5 times our cubed root a plus our cubed root b. So I've just taken the cubed root, just like when we're simplifying surds. If we had something like square root of 48, we know that 48 is 16 by 3. So we can take out, because the 16 is a perfect square, we can simplify that as 4 root 3. If you're doing a cubed root and it has a factor that is a perfect cube, you can bring that out the front. All right, now what do we have? So we've said that x cubed, so x cubed is our a plus b. Now what is a plus b? Let's work that out as well. So we worked out a times b, let's work out a plus b. Well, a plus b is also very simple. A plus 3 root 21 plus a minus 3 root 21 is just 16. So this is fantastic. So that's going to simplify to be that. Minus 15 times cubed root a plus cubed root b. Well, wasn't that our x? So let's just call that our x. Helps if you have the correct colour. All right, so we now are at the point where we have an equation to solve. It's a cubic equation. That's okay. We have a cubic equation to solve for x. Now we want to get the real number solutions. We don't want to get anything that is, let's just get rid of this. It's going to be in our way. We don't want to get complex numbers. So we have our equation. Let's do our usual thing and put everything on the one side and a 0 on the other. So we've got x cubed plus 15x minus 16 equals 0. How do we solve that? Well, we learn from the factor theorem that if we can find by trial and error a value of x that will make that work, then x minus whatever that number is will be a factor. Now, pretty clearly, it's pretty obvious. If you have x as 1, is a solution. Because 1 cubed plus 15 minus 16 is 0. So therefore, x minus 1 is a factor. All right, let's find, there's going to be a quadratic factor as well. Let's find that and see if that can be factorised and go from there. So when we're doing our polynomial division, if we're sort of missing a term, I like to pop it in just so that we don't mess up along the way. So we've really got 0x squareds. And we're dividing all of that by x minus 1. Leading term divided by leading term. Multiply back, sorry, goodness me, that goes up there and this is multiplying. Minus our x squared, do our subtraction, x squared, bring that down. Leading term divided by leading term, multiply through. Do your subtraction, leading term divided by leading term, and we get plus 16. And of course, when you multiply that through, we end up with a remainder of 0. If we didn't, we'd be aware that we've done something wrong because we already worked out that x minus 1 is a factor. So this here is what we've got now, is we've got x minus 1 times x squared plus x plus 16 equals 0. So any solutions to that will tell us what x is. Well, obviously x is either 1 or the solutions to this quadratic. So you negative b plus or minus square root b squared minus 4ac on 2a. What do we notice about this quadratic? The discriminant is 1 squared minus 4 times 1 times 16, which is very definitely negative. So both of those solutions are complex numbers. So the only real solution, in the system of real numbers is 1. So this whole expression here equals 1. And I reckon that's pretty cool.